All right, peeps, here we go. Moving on, same kind of problems. We're just going to practice and practice and practice. Please don't get bored. These are really, really important. And remember, you're going to have to do these without your purple sheet. Okay? I was having a conversation with some other math teachers this morning, and there are just some things you have to memorize. So, here we go. Cosecant 3 pi over 4. You do not have to change that radian measure into degrees. But for most of us, I think it's going to be easier to do that. So pi is 180, divided by 4 is 45, and 3 45s is 135. Pi is 180. So basically 3/4 of 180. All right, now where is 135? In our angle setup here, standard position, 135 would be right here. So one more time, I'll label. Not going to do this anymore. You know these. These are our labels. In standard position. This is how we label our angles. And here is the key. What's that? 45. And what do you know about a 45, 45, 90? 1 root 2. But remember, the moment I drew that triangle in quadrant 2, I knew something had to be negative. Unless you're in quadrant 1, there will be negatives in your problem. So what's negative in this one? This one right here. That's like your x, right? This is your y. And in quadrant 2, that's negative. All right, what's cosecant? Reciprocal of sine, so hypotenuse over opposite. So root 2 over 1. Answer to the question is root 2. All right, tan negative 40, or 240, I'm sorry, negative 240. All right, who remembers how we do negative angles? Go the other way. So this is the starting point, period, always. But if we're negative, we're going to go this way. So we're going negative 240. Tell me when to stop.
Stop.
Okay. And there is no exact place you have to stop, but does everybody understand why it's in quadrant 2? Okay. Now, this angle was 240. This is the one that matters. Right here. That's the one you have to figure out. How big is that angle? 60. Because we went 60 past 180. 180 is like your baseline there. Okay, so what do you know about the sides of a 30, 60, 90? This one's root 3. 1, 2. Bottom one's still negative. I want the tangent. Tangent is opposite over adjacent. So that's root 3 over negative 1, which is negative root 3. Now, I want you and your partner to work on E and F. They are exactly like we just did. So you and your partner, see how far you can get with E and F. You can turn around or switch your seat or something so you have somebody to work with if you're by yourself.
So 761. 761. Should be 270.
I hope you got
No, it's
210 for
210.
this first angle. Pi is 180 divided by 6 is 30 times 7 is 210.
I was locked in.
Oh, so you just. What do I have to?
Just right now we're doing a cosine of 210. I'm looking over Sydney's shoulder and she's got 210 down here. Is this where you have 210?
Yes.
180 and 30 more? Did anybody get negative root 3 over 2 as the cosine of 210? Perfect. Anybody not get it and need me to explain it? Negative root 3 over 2. So Sid's got this one in the same spot. She's got 225 in quadrant 3 also. Only this time her reference angle is 45. Because she went 45 past 180 to get to 225. I got negative root 2 because my secant is hypotenuse over adjacent. All right, feeling okay about that? Well, good, because all heck is about to break loose. The next one says find the sine of 90. All right, what's a little special about this?
It's like not bow tie.
It's not bow tie, and that's a problem. If you're going to do SOHCAHTOA, right triangle trigonometry, like we've been doing, opposite over hypotenuse, all that stuff, you gotta have a butterfly bow tie. And he says that when I draw this in standard position, here's where 90 degrees would be. And that's right on the axis. And there is no way to make a, remember, this is our goal, right? There's no way to get one of those from this angle. Does everybody understand that? So when that happens, you will not draw a triangle. If your angle is on an axis, these are called quadrantal angles. And if your angle is on an axis, so it's 90, 180, 270, you will not draw a triangle. Instead, you will draw a circle. Now, I want you to look at your purple sheet for a second, and I want you to notice something about your purple sheet. Where it said sine theta equals, we've been doing opposite over hypotenuse, but doesn't sine equal something else? What else does sine equal? Y over R. And what do you think that R stands for? Radius. So, if our angle is quadrantal, we have to draw a circle and use what are called the circular definitions. Y over R, X over R, Y over X. Those are the circular definitions. Now, how does it work? Well, when you draw your circle, this is the point I'm interested in right there. That's 90 degrees. When you draw your circle, you can draw it any size you want. So in other words, you can draw a little tiny circle and make the radius like 0.1, or you could draw a huge circle and make the radius 50. Most normal people draw what we call the unit circle and simply let the radius be 1. Now again, it makes no difference. You'll learn to understand that as we go through a few examples. But the easiest thing to do is to draw a circle with a radius of 1. If the radius is 1, then you should be able to tell me the coordinates of this point. What are the coordinates of that point right there? 0, 1. So in other words, X is 0, Y is 1. That's a point, X, Y, and R is 1. So what's the circular definition for sine? Y over R. So I simply put 1 over 1, and the sine of 90 is 1. How cool is that? Cosine pi. What's pi equal? Pi radians is 180, so we're looking at 180 degrees. So here's my setup. Where's 180? Isn't it right here? Again, you're on an axis. No triangle, no SOHCAHTOA. When you're on an axis, you're going to draw a circle. You're going to arbitrarily let the radius of the circle be anything you want. I'm always going to use 1. What are the coordinates of this point? Now I'm doing 180 now, so this is a different point over here. What are these coordinates? Negative 1, 0. So X is negative 1, Y is 0, that's straight from your point, and R is 1. Now I want cosine. What's cosine? By definition, X over R. So X over R will be negative 1 over 1. The cosine of pi, or the cosine of 180, is negative 1. Try I on your own. The tangent of 3 pi over 2. Try that one on your own. Tangent 3 pi over 2.
Whoa.
How many degrees is 3 pi over 2? 270. So again, you have a quadrantal angle, right? You're on an axis, 270. How did you label your point down there? Here's the origin. What's this point down here? 0, negative 1. So that's my X and my Y, and my R is 1. I want tangent. Oops, we have trouble in River City. What's the definition of tangent? Tangent is Y over X. So negative 1 over 0? Undefined. Yep, no answer. It's undefined. after we finish up this section, 2-3, we'll be moving into graphing. And when we start graphing the tangent, you'll see what happens because of these undefined. Tangent's gonna be undefined anytime x is 0, right? Secant, negative pi over 2. Secant, negative pi over 2. How many degrees is that? Negative 90, yep. Where's negative 90? Same place as 270, right? Isn't negative 90 down here? So there's my x, there's my y, r is 1. Tell me what my secant is. Well, cosine is x over r. So secant will be r over x. So here we go again. Did you get another undefined? Because it's 1 over 0. Cotangent 780. What in the world? 780. What do you think we're going to do about that? Where is 780? Can you get rid of a rotation? Not only can you get rid of one rotation, you can get rid of 2. Because isn't 780 more than 2 times around? 2 times around would be 720. So if I drew this, which no normal person's ever going to draw, you go round and round and then some extra. All you really care about is the extra. So how much extra are we going to have here? When we take out those extras, we're going to have 60 degrees. So we're going to draw a 60-degree angle. Now the good news is it's in quadrant 1. That means everything is positive. I don't have to worry about those negatives. I want the cotangent. Cotangent is adjacent over opposite, 1 over root 3. That's root 3 over 3. Now, guys, what we do with the circle and what we do with the triangle are basically the same. What is your circular definition for cotangent? X over y. I want you to look at this triangle. Isn't this the x side and this is the y side? So x over y is the same as adjacent over opposite. They're connected. They're exactly the same thing. All right, last one, cosine 0. Where is 0? Isn't it right here? It's a starting point, that's 0. That's quadrantal, let's draw a circle. The radius is 1. What are the coordinates at that point? 1, 0. So x, y. What's cosine? X over r, so that'll be 1 over 1. The cosine of 0 is 1. Now, again, just for your own information, because I'm sure some of you are wondering, when I said you could let the radius be anything, it's true. What if I let the radius of my circle be 2? Well, then this point would be 2, 0. So when I built my cosine and I put x over r, won't I still get 1? Yeah, it's never gonna matter. So just use 1 and keep life simple. All right, let's see if we get number 6 done. All right, now I'm still keeping my fingers crossed we have school tomorrow. All right, here we go. Sure doesn't look like it's gonna snow, it's beautiful outside. All right, use the given to find the desired values. The cosine is 2/3, and the tangent is negative. Less than 0 means negative. So I want you to think about your butterfly bow tie. And this is like a puzzle. We gotta figure out where will the cosine be positive 2/3, but the tangent will be negative. Could the cosine be positive 2/3 in quadrant 1? Yep, but will the tangent be negative up there? No, because this would be √5 and the tangent would be positive √5 over positive 2. Okay, so that quadrant doesn't work. The quadrant below works, Meg says, because in this quadrant, let me just draw that one triangle so it's not so confusing. Is the cosine still 2/3?
Yes.
But now, this third side, Pythagorean theorem, 9 minus 4, will be negative √5, because I'm down below. It says find the sine. All right, what's the sine of this angle? Opposite over hypotenuse. Negative √5 over 3. What's the cotangent of that angle? Adjacent over opposite. 2 over negative √5, or negative 2 √5 over 5. I'm gonna stop there and make sure you followed that logic. They told me the cosine was positive. Okay? So we said that could happen here. Positive 2, positive 3. Problem is, the tangent won't be negative. And the problem says the tangent has to be negative. Then we said, okay, what if we do it down here? Positive 2, positive 3. Now, the tangent is a negative number. So that's the right picture. And then I answered the question. I found the sine and the cotangent. We will pick up there tomorrow. Good work today. Almost ready to start graphing.